Perfect.
There we go.
Thank you, sir. And we got spare parts left.
Yes.
Okay, so today we're getting back to our Watermaker install, which is the new Schenker 100 that we just received. And we've got a few days of installation work into this already that we haven't really been able to record because it's all been like jigsaw puzzle, just setting up the foundation of where we're going to put everything, finding the space necessary to put all the components in where they can work comfortably together within the confines of this new cabinet that I built. That's the biggest requirement. And still being able to make everything work and be accessible for future service. So those are my main requirements. So we've put a few days of work and thought into this, and it hasn't been really worth recording a lot of that stuff just because it's unique to this cabinet and it's unique to the boat. So that's just stuff that we're going to walk you through what we decided to do and how we hooked it up, what all the component features are, how they need to be hooked up and connected to each other, and how the system works in general. But for now, yeah, we're just getting back to, now that all the components are mounted, we've got the rough plumbing in, and we're getting ready to do our first test. So we just got to finish up a few wirings, tighten things up. We've got to mount the main unit in here. It needs to be hard mounted so that when we're sailing, of course, you can see it's on the lateral line of the boat. So if we're heeling either way, it's going to want to fall over. We have built the new brace underneath that it will lock it into position. So at the bottom, it's perfectly locked in and secured. You can see it's got a rail on each side and in here as well. So it's sandwiched in between these two pieces that'll stop it from moving this way. But the top will still fall this way or that way if we're sailing. So that's what we're working on making the mounts for right now. And that's just going to be some custom aluminum strapping that we're cutting out, and we'll bolt to these and then bolt into the side walls beside the unit, and that will reinforce it so that it can't fall over when we're sailing. Aside from that, it's just going to be a matter of tidying up all of our wiring, checking everything, confirming, and then bleeding all the air out of the system because it's all new installation, so all the filters and everything might have some air in it. So there's a startup procedure that we have to follow, and we're going to get to that once we show you everything and how it's hooked up. How's it going out here, Steve?
It's going pretty good.
Getting the holes drilled?
Yep.
Oh, good. Got this one drilled out, okay. So we got 2 1/4-inch holes for mounting screws, and then a 1/2-inch hole for the actual studs on the Watermaker. Just finishing the last one now from the looks of it.
There we go.
Perfect.
This one here, looks like it was here. It was in a bit, or is that in the right spot now, you think?
Push it in so it's up against the wall.
Oh, okay, that way. Yep.
You can drill new holes if you want, if they don't line up, or if they do, then put it in the same. It doesn't matter. Okay, so the last thing we need to build down here is our pressure switch, which is an emergency pressure override for the water pump, so that if the hydraulic pressure inside the unit gets too high, it's going to shut the pump off so that it doesn't just keep pressurizing until something explodes or blows up from water pressure. So that is this guy right here, and you can see we're going to put it right in our high pressure line here that comes right off of the pump, which is right over here. So that line comes straight down to the outlet of the pump, which is, this is our new high pressure pump here, out to here into this pressure switch, and Steve is just working on the T-valve here now. So it's high pressure, so we need to make sure everything is nicely sealed with Teflon and tight. Okay. And then that's our brass adapter, so we need to put good Teflon on both sides of this, the inlet and the outlet. And the other one is here. Okay, so there's our prepared T-fitting. So the brass and everything has all been Teflon taped, everything is tight, ready to go. We've put some Teflon tape on the fitting itself, the pressure switch. So now if you just want to tighten those together, you should be able to just twist it on. Okay. Alright, so now we can install that into this line. So you can push it into here. And next clamp on the other side. But I think we can shorten that line a little bit also.
Yeah.
Okay, so like I said, this has been a fairly complex install. The ZEN100 is a lot more, well, technical than the last one that we had. It has a lot more electronic sensors, hookups, control systems, monitoring devices, things like that, which are all great. That's why we wanted to go with this system. I will tell you that it did take some time to put it in, to install it. It wasn't that tough, it was just time consuming, and we've had it mixed in with some other projects at the same time, like refining this whole cabinet and everything else at the same time. So we've had our challenges with it. But I will say, it comes with a very comprehensive manual that goes over everything very thoroughly, wire by wire, valve by valve, everything that you need, all the checks, everything that they recommend for the installation, everything. It's a very, very well laid out manual, I must admit. So good job, Schenker, on that one. I really appreciated having this one as our reference. I didn't have to go searching for anything. Pretty much everything was right here. A couple of questions I did have, and customer support was right back to me, usually within a few hours. So very happy about that. But the general layout of the system is very close to the last one that we installed. You remember we had the ZEN100 installed, and it used to be here where I'm sitting. It was a much smaller unit, so the ease of installation was obviously a lot easier. But this one, we've had to run in some new things, including a water intake. This one needs a dedicated through hull. So the other one I used to share the through hull with some other devices on board, and it had a 1/2-inch water intake. So the 1/2-inch water intake would supply everything that it needed adequately, no problem. But this one needs minimum 20 to 22 millimeters or 3/4, 7/8 of an inch. So I have one 3/4 inch through hull that we made available. It was for the head intake on one of the forward heads in the boat. So basically I disconnected that head from that through hull, and we're moving that over to the other side, because it's fine for the heads to share one through hull because they don't always work at the same time, not a big deal. But I can't have this sharing the through hull with other things in the boat in case something's turned on and then all of a sudden it becomes restricted in its water flow. So we've got one dedicated through hull now for this, and that is one of these lines coming right up here. You see that black line right there? That's coming from the through hull, which is just underneath me. That comes around the back, and the first thing that goes through is a small strainer, and that's a seawater strainer that just takes out any particles below the boat or anything like that. And then from the strainer it goes straight into the intake of the pump, and then the pump takes the raw salt water, pressurizes it to 200 psi, and takes it into a sediment pre-filter. And I'm going to show you all that here in a minute. But basically, yes, everything is laid out, installed. You see, these are the brackets that we were just fabricating here. So we got one on this side that's running right into the side of the Watermaker, and one on this side. So we got two brackets. The whole thing is wedged in here. It's bolted down on this side. So this thing is rock solid. She is not moving. She is physically part of the boat now. And they will handle anything that we're going to throw at in any kind of sailing conditions. So we're in good shape. So very happy about that. And if you look at the back here, this is the high pressure line that comes off the pump. And this is what we were hooking up earlier. This is the high pressure switch right here. So if the switch detects that the pressure or the hydraulic pressure is too high inside the unit coming out of the pump and back pressuring through the line, it will just physically shut off the pump. So the pump shuts down, system goes into alarm status, lets me know there's an issue, and we start to go looking for the problem. Usually it's going to be a filter or something like that, plugged filter, so that just means we need to check our maintenance. But Other than that, that's all there is accessible back here. So now we can go ahead and we're pretty much going to close this all up. Everything is organized, installed. You can just see the back here. This is my new water manifold. So we've installed all these new valves here. We got rid of all the old French poly tubing. Everything is gone. So now we are 100% solid brass and PEX tubing. That's going to be a big advantage because that I can operate on and service anywhere. And we have a whole slew of fresh spare parts on board. So anything happens, I've got lots of spare tubing, spare fittings, spare couplers, crimp connectors, everything. So we're in good shape. Now, to give you an idea of what we've created here, you look into the depths of my cabinet that we just built and outfitted. Everything has a new place. As I said, we moved the entire water system, all new components, everything relocated, all new plumbing, new fittings, everything is new. So if you look inside the cabinet, I'll outline where we start here. Now this obviously again is the desalinator. You can see that's the ZEN100 sitting right here. Now we're just looking at the other side of it. So that line that I showed you earlier comes in from underneath, and all of down here from below this point right here is below the water line. And that's important. We need to have all of the raw water intake components, including the head of the pump, needs to be below the water line. If you don't have it below the water line, it's going to start sucking air, and then you're going to have issues. So you'll notice that all of these components are just below the water line. So that first primary water line comes in from the through hull and goes right to this little seawater strainer right here. So that is our seawater strainer, and then it comes up through here, and this is a check valve. So it's a gravity feed check valve, because what happens is when we need raw water, it will automatically come up through this T-fitting and go straight over to the pump. Okay, so that line here goes to the intake of the pump on this side. And you see here's our intake and our outlet. Now, backtracking to the seawater strainer, you notice that it comes up through a check valve right here. And this check valve is there so that it can choose between fresh water for rinsing or seawater for just running normally. The seawater comes in from this side, the fresh water comes in from here. So you just see this line right here comes up to this, and this is a solenoid off of the carbon filter, which is this device right here. So this carbon filter is here so that if we have any chlorine or chemicals in the tanks or anything like that, when we go to flush the system, the carbon filter will remove all of those chemicals from the water before it goes into the reverse osmosis system. Otherwise it will destroy the membranes. So this said here, this is hooked up to our freshwater system. It's on its own manifold over here, so it has its own water intake right there. And that controls the freshwater system coming in to the desalinator for freshwater rinsing. And that's what that's there for. Basically, you need to freshwater rinse it if you're not going to use the unit for a little while. That's going to be important because you don't want to leave salt water just sitting there for too long a time, okay, on the membranes. So if we're using it every day, we don't need to use fresh water because it'll use about 4 gallons, I think, to freshwater rinse the whole thing after you're done making water for the day. And if you're not going to use it for a while, like a week or something like that, then definitely a good idea to rinse it with fresh water. If you're going to use it again tomorrow, then don't worry about it. Don't waste the water. Okay, so from here it goes into the pump, and then you see the outlet of the pump comes straight up this tube right here and across the back and into the pressure switch that we showed you on the back side here. Now from the pressure switch, that's just a safety device again, so that if we have too much pressure in the system, it shuts off the pump. You can't overload the system. But then over here is our pre-filter. So this is the sediment pre-filter cartridge, and this is the pressure tank that helps eliminate some of the pulsations from the pump. Okay, so from the sediment filter, now is when we take this line, goes straight across, you'll see across the top, and it comes right over to here and into the inlet for the watermaker. And that is going to be running at about 200 psi, and then this is our high pressure instrument right here. This gauge here tells us exactly what the pressure of the system is when it's running, and usually we average about 6 to 7 bars of pressure. That's how much it runs at normally when it's fully active. Okay, now this device right here is another electronic sensor. This is a bypass device, so that if the water quality that the system is producing is not up to quality, if it's too high in total dissolved solids, the electronic sensor will automatically activate this solenoid and cause the product water to discharge back to the discharge and go straight out the back of the boat with the rest of the brine discharge. It's a nice feature to have so that you don't contaminate your tanks with that, you know, first 1 or 2 minutes of water when it's not that high quality, because when you first start the system up, it's never going to be as high quality as after it's been running for a little while and the water's been flushing through the system. So this is just an automatic discharge device that detects the quality of the water and tells it when to turn back on and start actually feeding it into the tanks. Now this system has a much larger, much more powerful pump than our last ZEN system, and that's this guy right here. And we ordered a 24 volt version this time because now of course I have 24 volts available, and that means that it will draw half the amperage at the same wattage. So that keeps our cable size much less than what we would need if it was in 12 volts. Now this system, it'll run continuous as long as we need it to, but it does need to be ventilated, so we always have to make sure it's in an open area where there's going to be a vent, and of course we do. I've got it vented out the back there, so there's lots of cooling. The actual pump is on the end of it. That's right here, as you saw, and there's our inlet and our outlet, both hooked up. The rest of this, you got to remember, this is all our water system completely, so this is now a fully self-contained water system for the whole boat. So this is our freshwater pump for the boat, so this is what runs the house system, and that's the tank strainer right there. If any debris comes out of the tanks or anything, it gets caught there, and we just clean that out as periodically as needed. This system here, that's our drinking water reverse osmosis system. So while we have just installed a desalinator, the desalinator is for removing salt from seawater and making usable, drinkable utility water. Now that will take seawater that's down about 30,000 parts per million on average, and it will reduce it to about 300 parts per million. Okay, so that's well within the limitations of what safe drinking water is rating at, which is 500 parts per million and below. Now the drinking water system over here further takes that water and makes it more pure, just like you would have in your household. If you got a reverse osmosis system in your house, you know exactly what I'm talking about. This will take the water from the desalinator that is pump the water into the tanks. It will take the water from the tanks and run it through here, and it has its own storage device, which is a 2-gallon tank that's below the floor. And this will take that 300 parts per million and reduce it down to by about 90 to 95%. So our product water is usually less than 20 parts per million. Very, very clean, very, very pure water, much like the same type of water that you would buy in a store. But we don't have to buy it in store, hence we don't need to use the plastic bottles and keep dispensing, throwing plastic bottles away. We've been using this for 16 years now, and we use it every single day, and once a year we change the filters, and about every 3 to 4 years I change the membrane. Other than that, it just works on its own. It does its own thing. It has this one pump right here, and that pump is just a booster pump. So our household system runs at about 45 to 50 psi, pounds per square inch, but this works better the more pressure you give it. So with this pump, the booster pump brings it up at, well, from 12 volts DC, it will boost the pressure from this one up to 100 psi. So it's a low volume pump, not a high volume, but it will pump in enough pressure here that makes the membrane work much more efficiently, much faster, and much higher quality water, because the more pressure you have, the higher the quality of the water is going to be, the product water. So this has been a system I've been using for a long time, and we just reintegrated it into the new system, and it's still working perfectly. So we'll be testing all that very soon also. Now the last components are basically the control boxes. So we got the computer box and the pump box here. This is where all our wiring is done. And I'll open this up so you can have a look. It's just got the 4 screws on each box because they are meant to be weather resistant. Now, of course, they're not waterproof, but they do need to be able to reasonably take splashes and stuff like that. So if something explodes in here and it gets wet, it just runs off the pump box instead of just soaking the computer. This one has some fairly elaborate electronics, as you'll see. Now, don't get scared because we have to hook all this up as part of the install, and it may look very complicated, but again, if you remember my theory, it's just break everything down one wire at a time. And you'll see every sensor here has one wire. So each one of these sensors has one wire, and they're all labeled and they're all color coded. You run them all back into the box. The box has separate inlets for each separate wire, and then on the circuit board it is labeled specifically with the color coding of what wire you need to hook up to each terminal. So it's almost impossible to go wrong as long as you take your time and do it one wire at a time. You'll see we've got everything hooked up, and that's all running and proper. Now The system does have manual bypasses, which is great. That's one thing I always insist on, because if all the electronics fail, I want to be able to turn on the pumps. So if something happens to the circuitry and it's just blacked out for whatever reason, these switches here can be used to manually activate the system in an emergency or just as a backup application. So these switches can be switched to on, and that will activate the pump, bypass anything that's going to shut it off, and just keep it running so that we can at least have water in an emergency situation until we get the problem resolved. So that's a big plus. Had it on the last system, insisted on this system as well. I'm very happy that we have it. So all in all, very good. Now the last box is this one over here. It's a little bit more simple, but I do want to show you all the components of the installation. So let's have a quick look. Okay, so this is the pump box. So this harness right here is the 2 power wires and the power switch, like the bypass switch for the pump. So this harness comes down and just goes straight into the side of the pump. Now from there, the only other things required in here is this is where our main power hookups are. So we have, you see, a positive and a negative, and I've gone with 6-gauge cable, which is more than adequate for handling the amount of current that this system is going to draw at 24 volts. It's a 400-watt system, so we expect it's going to draw somewhere around just under 20 amps, like 17, 18 amps at normal voltage. And that is the only thing that we have to hook up in here, is just the 2 wires, and then to connect the computer box to the pump box, and that's this 3-wire harness here. So these 3 wires just come in, and that connects to give power to the computer box from the main cable, and then the computer box sends the trigger for the pump to turn on and off from the computer box into the pump box. So hence 3 wires. 2 are power, 1's a trigger. And that's all that's in there. Simple. Basically 5 wires to hook up. Everything else is done for you. And then all these other sensors are just hooked up over here. And then once you got all that hooked up and checked and verified and double checked all your connections, that's when you hook up your power cables, and then you can plug in the remote control and see once you've activated your power and make sure that you've got everything hooked up properly. Now you can see obviously we already have it turned on because I've done all these checks already. But now if we take this wire, which is still here, we haven't run this anywhere yet, but this is our remote control wire here. And here is our remote control. So this is the new control panel. I've still got the protective coating on it because obviously we haven't installed it anywhere, so I don't want to mess up the display. But it's just a 4-pin connector. So we're going to line that up and plug it in, just like so. And then we turn it over, and it should turn on. There we go. Schenker. And this is a full touchscreen control system, so it's going to give us a readout of every component of the system. You can see it comes up. There's ZEN100. System is in stop mode, and we got stop, start, flush, salinity. It gives you a meter readout of everything to do with the system. Tells you if there's, bad problems or got a bypass or discharge or anything like that. You can set up any automatic features you want in the next screen, so that's all here. It's all outlined in the manual. So again, you're going to read the manual to understand all of this stuff. It's not complicated or difficult or anything, but you do have to just look for what you need. So the first startup procedure, we're going to go to the manual now, and it's going to tell us what we need to do the first time we start it up. So that's what I'm going to look for here. Okay, here we are. Functioning and use. First startup procedure. So first startup procedure, preliminary checks, and we've already gone through these, but verify all components and hoses are connected correctly. Got it. Verify the 5-micron filter and active carbon cartridges are installed. Check. Check the seawater inlet valve and the saltwater drain valve, if existing, are open. Check. Check the reset valve is closed, and that's the device on the top of here, and we just have to make sure that it's unscrewed all the way. That means that it's closed. Okay. Check the freshwater pressurizing pump of the boat is on, which it is. You can hear it's running in the background here sometimes. And check the gray valve on the action carbon filter is open, and that is this one here, so it can be turned off for service or on when we're using it. Okay, so that's all good. So startup procedure: open the depressurization valve, unscrew the valve, and that's this device right here. On top of all the Schenker models, they have this depressurization valve, and it's there to help evacuate air from the system. So they want us to unscrew that, so I'm going to unscrew it. Just one, 2, and 3. Okay, so we're just letting out the pressure from the system. Now, access the startup procedure through the function of the second page, and that's what we were just looking at here. So the second page, we go there, we go automatic startup and hit start. So it's in system startup, open pressurization valve. We just did that. Now it's going to count down. Okay, there, the pump just turned on. You can hear it cavitating a little bit, so we got a little bit of air in the system, and that's what this function is designed to do, is remove air from the system. So it's going to count down here, think for about a minute, and then it's going to tell us to close the valve. When it triggers us, like tells us to close the valve, we close it, and then it's going to run for another minute, and then we go from there. So activate the startup procedure, close the depressurization valve when the display shows the specific message, and wait for the completion of the procedure. Okay, so now we just wait. You can hear it's already got most of the air purged out of the system. I'm not hearing any cavitation on the pump anymore. You can hear the energy recovery system starting to make its impacts, and that's where it's taking 200 psi up to hydraulic pressure of 800 psi, all inside this energy recovery pump right here. Okay, now it's just told us to close the pressure valve. So we're going to close the pressure valve. Okay, it's nice and tight, it's closed. And now you'll start hearing the high pressure pump start building more pressure within the system. There it goes now. If you look at our meter over here, you can see it's running at 6 bar right now, and it should build up between 6 and 8 bars as it gets to full pressure. So it's doing well right now, it's sounding good. Everything is running good. The pump is very smooth. I must admit it's very quiet compared to the last ones that we had. Okay, and that's it. So that is its first startup procedures. Now if we go back to our control panel, it says system stop. Okay, so it is finished. So now if we want, we can go into a full normal start mode, but before we do that, just in case we have any hydraulic issues with the hoses or anything like that, I don't like to leave these computer circuits open, so I'm going to close those back up again just in case we have a hose let go or something stupid. I mean, we do not want to have these saturated in salt water, trust me. That would be very bad. So let's get these guys closed back up. Okay. Alright, we're secure. So now we will go into a normal startup mode and basically just push start. Okay, system running. Salinity says S wait, salinity wait. And you can see right there it says diverting to discharge. So that means that the quality of the water that it's producing is not up to quality yet where it wants to start putting it in the main tank. So it's diverting it to the brine discharge and just evacuating it off the boat. So we wait until this says salinity okay, and then shortly after that you'll see the divert to discharge turn off, and then we are starting to collect water. Okay, everything sounds good. Operating normally. Can't believe the large pump is very quiet, very nice. But yes, as soon as it sucks in any air or anything like that, it starts to cavitate. It gets very loud, you notice right away, so you've got to keep an ear open for that. Once you get used to the sound, you know what to listen for. Okay, salinity okay, system running, and now it's just telling us time, how much it's run. So it's on for 1 minute, 2 minutes now. And you can see it's just indicating the direction of the water flow into the unit and through, and it's running between 7 and 8 bars, showing us right there. Alright, we're going to let that run for a little while, and then we're going to disconnect the discharge hose, like the product water discharge, and we're going to do a test there and see what the TDS is that we're getting from the system and how much water flow. So we'll come back to that in a few minutes once we let it run for a little while and get itself cleaned up. Okay, so you can see I've disconnected, I've bypassed over here. This is the one going into our tanks forward, but I just hooked up my own blue line here. And I'm just running it into this bucket. We're going to test the product water right here. So I'm just letting some of it run through, but that's how fast we're making fresh water from seawater right there. That's pretty impressive, I must say. So I'm just discharging that first little bit. Now I'm going to fill up a glass for testing. Okay, that's all we need there. And then we need to check the time. Okay, it's 3:44. I'm going to put this into this blue tank here. Okay, and we're just going to let that sit. That's an empty 5-gallon container, so 20 liters, and we're just going to fill it up to the line, and we'll see how long that takes. So we started at 3:44. Now, for the tester, we got just a basic TDS tester right here. It's just an electronic meter that puts a current into the water and tests how much dissolved sediment or dissolved solid there is in the water. So we turn that on. So you can see it's on. It's already leveled at 0 parts per million. And wow, 224. That's better than I thought. For first time out, that's less than 300. I was expecting 300, but yeah, we're putting out very good quality water. This water, less than 3 minutes ago, was in the ocean. And now it's 224, and that's less than half the required amount of dissolved solids for safe drinking water. That never ceases to amaze me. Literally, this minutes ago is seawater. Wow. You want to try it?
Sure. It's good.
There, Neil, you want to try?
Yes.
Very good. Not bad, eh? Considering it is seawater. We drank the potion and we didn't die.
Yeah.
Yeah. No, it's good. Very surprised. A lot of homes don't have this quality water. 225 parts per million, that's very good. Okay, we'll shut that off. And now we'll just wait for this tank to fill up. But according to our display, you can see right there, it says it's putting out 108 liters per hour. So it's actually a little bit over the rated specification of 100 liters per hour, which is great. And that's at 26.4 nominal voltage. So that's how much voltage we're getting right now. And I will point out to you that right now we are running off solar power. Because right now we have more solar power coming in than we're using on the boat, and the batteries are almost full. So this system is running 400 watts off solar power exclusively right now. That's amazing. Making fresh water from seawater from solar power. Yeah. Okay, so we are just, yeah, we're up at this level right here now. So we're at 20 liters nominal. And the time is 3:57, so 13 minutes. So it took 13 minutes to do 20 liters. And I think that's pretty much right in line with what it's saying it's supposed to be producing. So yeah, at 100 and something liters per hour, that should work out to about 20 liters, 18 liters, maybe every 10, 11 minutes, somewhere around there. So yeah, that's good. All right, so I'm very happy with that. Now we're just going to let it run. I'll keep running till it overflows the bottles. We'll fill this up as one of our backup water containers. Put it back out on deck. Then we'll hook the system back up and top up our water tanks. Because I think we're going to fill up our water tanks before we shut it down today and then call it a day. Start to clean up our mess. And I think it's almost happy hour by then. Alright, good stuff.